Hello, everyone, and welcome to a brand new series called Pulumi for IT Pros. This series is focused on the Pulumi Infrastructure as Code tooling, and it's a from beginners guide. So if you've never seen Pulumi before, then you will be able to get started with this set of videos from scratch. But it's focused particularly around IT pros, and we'll talk about why that's important in a minute and why it might be a sort of different experience of IT pros versus developers. But that's what we're going to have a look at in this series. For those of you who haven't done any of my video series before, my name's Sam. I'm a solution architect based in the UK, and I spend a lot of time working with cloud, and in particular Microsoft Azure. I'm a Microsoft Azure MVP, and I do a lot of presentations and community content around infrastructure as code, DevOps, cloud automation, all those sort of things. Got plenty of other video series if you're interested in other tools, particularly Microsoft native tools like ARM templates and Bicep. Check out the rest of my YouTube page for that. But Pulumi is something I've been working with for the last couple of years, and I really like this language, and it's something that I think people could really enjoy, and so it's something I want to expand on. But it can be a little hard to get started with, particularly coming from an IT pro world, and so this series is focused on how to get started and get going with using Pulumi and why you might want to do that, what the benefits are, and all the great things it can do. So let's get started and talk about what Pulumi is, why you might want to use it, and why, coming from an IT pro perspective, you might have a different kind of viewpoint. So if you've never encountered Pulumi before, it is an infrastructure as code tooling, not too dissimilar from Terraform. It's a third-party tool, so it's not made by any of the big cloud vendors or anything like that. It's a third-party tool which supports multiple clouds and non-cloud resources in a very similar way to Terraform. So if you've ever used Terraform, you know you can deploy to Azure, AWS, GCP, Kubernetes, VMware, all sorts of different options. Same setup with Pulumi. You can deploy to all of those different resources. It operates in a stateful way, just like Terraform. So you have a state file where you record all of your operations, which allows you to do some more advanced things in terms of doing things like what if scenarios, destroy, updates, those sort of things. And we'll cover that side of things in a video on its own at some point. It's declarative, so you are declaring what you want to create, not how. It's idempotent, so you run the same code over and over again, you should get the same result. And all the code is open source. You can view all of the tools and all of the code that goes along with it on GitHub, and you can use Pulumi completely for free. So if you look at the website and Pulumi has an enterprise edition that you pay for, you don't need it. You absolutely can do everything we're going to do in this course using the free version. No cost and no need to use any of their cloud services if you don't want to. So that's very important. So yeah, Pulumi has all those things. Again, if you've used Terraform, you will know that they are very similar. It uses the same sort of approach. And obviously the question that's going to come up there is, why would I use Pulumi over Terraform? And so let's have a look at the benefits, and these are the reasons why. And in my personal opinion, I enjoy working with Pulumi more than I do Terraform. I think it's more flexible. I think it has more features, and hopefully we'll see that over the course of these videos. So the big headline benefit of using Pulumi is the fact that you can use real programming languages to write your infrastructure as code. So if you've ever used Terraform or Bicep or ARM templates, you will know that the language that's used there isn't a full programming language. It is a domain-specific language, a DSL, that's been created for that particular tool. So for Terraform, you've got HCL, Bicep's got its own language, ARM templates is using JSON. They're not programming languages, they're more things that are used to just define objects and so on. Pulumi allows you to actually write your code, write your infrastructure in an actual programming language. And it supports several. It supports Python, TypeScript, Go, .NET, Java, and YAML, which isn't really a programming language, but it's an additional option. And this has a few benefits. So one of them obviously is if you're a developer or you've worked with a particular language before, you can come in and you can use that language straight away, and you can work in something that's familiar. You can work when you're working between an application you've written in, let's say .NET, you can go and write your infrastructure in .NET as well. Now, coming from a developer perspective, that's maybe a big benefit. Coming from a IT pro one, maybe not so much. We'll talk a bit about that more in a minute. But one of the really big benefits of the fact that you can write your infrastructure in a real language is that you can take advantage of all the features of that language. And that's really powerful. So take a very basic case. If you've ever tried to write a for loop in Terraform or in Bicep, which doesn't have a native language behind it to do that, you will know how painful that can be. Terraform has some for each loops and so on you can use, but they can be very confusing and they can be very difficult to get the right output that you want from them. Using Pulumi, there's no Pulumi specific for loop. You just write a for loop in your language of choice. You just use what you would do normally in that language to write a for loop and loop over the Pulumi bits in it. That's really powerful that you can do that. And obviously, a for loop is just an example that you can use pretty much any part of your language. And so that makes it really powerful because it makes your life easier, but it gives you more functionality as well. So if you get to a point where you're looking to do something that perhaps Pulumi doesn't do, or you're looking to do something that needs to happen outside of your infrastructure. So a good example there is, say you want to read in some values from a JSON file that's going to determine how your infrastructure gets created. You can just use the native language to read a file, whatever that might be in your particular language. If you need to do stuff that Pulumi can't do, you can just drop out to your language and do some normal programming in that language. So I've got some examples we can look at some point where I'm doing some Pulumi deployments, and then there's a certain thing I can't do in Azure that isn't supported by the infrastructure as code type piece. So in exactly the same file, I drop out and use the Azure SDK to talk directly to the Azure REST APIs and do that particular thing that I couldn't do in infrastructure as code. And you can do all sorts of things. So it gives you a lot of flexibility. You can also couple that with some more advanced features as well, and we'll have a video on this, such as the automation API. So Pulumi has this thing called an automation API, which allows you to take your infrastructure as code, and because it's effectively just a program in the language you've written, an executable or whatever, you can treat it that way. So it becomes very easy to write automation around your infrastructure. The common example of this is to use the automation API to create an actual API that you can call to provision infrastructure. So if you wanted to offer a self-service system where users could come in and say, I want a VM already configured with all of the company standards and all that sort of thing, you could provide them with a web application that pulls an API you created using the Pulumi automation API to go and provision that infrastructure. And that's just using your language of choice, and it will present that as an API that can be called, and an application that will run in the background that will execute your infrastructure as code. So I think it's really powerful that you can use real programming languages as part of Pulumi to deploy your infrastructure. It adds a lot of flexibility. It's okay talking about that, but we'll see some examples soon. Hopefully you'll see that power as we start using it. But there are a few other benefits of this as well. One I like to call out early, it seems really small, but actually it's been a big benefit for me, is the encryption of secrets in state files. So if you've ever used Terraform, you will know that if you deploy anything that has a secret in it, let's take the obvious example, it's an Azure storage account, it has a storage account key. That key will be stored in your state file. And in Terraform, that is stored in plain text. So if somebody gets access to your state file, they can read that key in plain text from your state file. This has been a big issue for many years. A lot of people have complained about it. I have lots of issues talking to security teams about this fact. And yes, you can mitigate it by locking down your state files and all that sort of stuff. But ultimately, it's just a pain having that. Pulumi has encryption for your state file out of the box. So any secrets that end up in your state file are encrypted and are not readable as plain text. Seems like a fairly minor feature, but it can be a massive benefit if you're having to deal with your security team, or if you're just concerned about security in general. So this is a really big one for me. Another one is the coverage of resources. So, and this particularly when you compare it to Terraform. So Terraform craft all their providers, and so when there's a new update to Azure, AWS, or so on, you have to wait for Terraform to come in and make the changes to get the new release into the provider. And that can take a while, particularly depending on how busy they are, how many resources they are. I know there's been some issues in the past with Terraform not accepting community contributions and so on. With some of the providers in Pulumi, not all of them, but there are some providers who are usually labeled as native, which have been created by Pulumi, and they programmatically generated based on the APIs of the cloud provider. So there is an Azure one, an AWS one, and I think there's a GCP one in preview. Those providers have 100% coverage of all of the Azure APIs. So everything that's in Azure should be creatable using those Pulumi providers. Now, that's not all roses. One of the benefits of the handcrafted approach to Terraform is they can sort of paper over any issues in the APIs. There are plenty of problems, particularly focus on the Azure APIs, and there are plenty of problems in the Azure APIs and the way some of them have been designed, the references, some features that are missing from the APIs that you can't do, the difference between the data plane and the infrastructure plane, all those sort of things. With Terraform, because they handcraft them, they can add some additional logic on top of the API to deal with some of those issues. With the Pulumi native providers, because they're auto-generated, you don't get that. So you are balancing the benefits of 100% coverage against not covering over those issues with the APIs. Now, the nice thing is that Pulumi also has the sort of non-native or the classic providers, which are actually based on top of the Terraform providers. And so they have that sort of abstraction on top of that. If you really want to use some of those features, you can use the older classic APIs, so classic providers, and you can use them alongside the native ones. We'll see all that in action, but you can do both. So you can pick and choose, but generally we'll be leaning towards using the native providers wherever possible. Finally, another big benefit is Pulumi has this concept of a stack. A stack is a sort of an environment, dev, test, prod, and each one can have a configuration file associated. And you can actually now have hierarchical configurations, and to some extent that allow you to define multiple different environments, use the same code to deploy it, but vary them using the different configurations. Now, this is achievable in something like Terraform with things like workspaces, but in my view, it's a bit harder to get going with and to actually get to work. And we'll see how that works, but I think that's quite a nice benefit. I'm sure there are plenty of other benefits I've missed here, and we'll see them as we start working with the program. So why IT Pros? Why are we focusing this course on IT Pros? As I mentioned, one of the big benefits of using Pulumi is that you can use an actual programming language. This is really powerful, but it can be a bit off-putting if you're coming from the IT Pro side of things, where perhaps you don't spend every day writing code, particularly not proper programming languages as opposed to scripting languages, and you're not confident in using that sort of paradigm of writing full-blown applications. And so it can be off-putting. And I've spoken to a number of IT pros who perhaps looked at Pulumi and said, oh, that's for devs, still clear of that, I'll stick with Terraform or Bicep or whatever. And so what I want to do with this course is just to show that actually, yes, it is a programming language that I could be writing in, but actually a lot of what you can do in Pulumi doesn't involve massive amounts of programming knowledge. If you can read the documentation and see how to define a resource, most of the resources are just key value pairs. They're not too dissimilar from how you would write it in Terraform. If you can then learn a few paradigms like for loops, if statements, those sort of things, which again are not massively different from your scripting, then you can unleash quite a lot of the power of Pulumi. And as you get more comfortable with using that language, as you get more experience with doing that, you can then start doing some more of the advanced things. And so I want to cover that in this course. I also want to perhaps show you some of the things that maybe are a little bit more complicated, that do look like you need a bit more programming knowledge, but actually if you just understand these individual parts, you can use them and leverage them. And maybe, yes, you don't grasp all of the underlying logic that's going on with them, but if they make sense in terms of how to use them, then you will be able to pick this up pretty easily. And so I've worked with a lot of people who wouldn't call themselves developers who have picked up Pulumi pretty easily, and I'd like to hope that I can help you pick that up as well. As I mentioned, this is focused on IT pros, but there is no reason if you're a developer you can't use this course as well and get going with Pulumi through that method as well. I'm not going to be exclusively focusing on IT pros, but that's the sort of viewpoint we will be taking and as we move through the course. So what we'll do now, the rest of this video, we're going to look at how we get set up, get Pulumi and stuff installed, and we're going to run our first Pulumi deployment, and then we will leave that there for this week, and then after that we'll start looking at building your own and doing some more advanced things after that. So let's hop over to my development machine and we will get started with getting things set up. Okay, first thing, we need to choose a language we're going to work in. Everything we do in this course will be possible to achieve in any of the supported languages, but obviously we need one to use on the course and do for demos. And so for this particular set of videos, we are going to use Python for two reasons. Firstly, if you're coming from an IT pro background, then Python is probably the closest option to a scripting language that is supported. There was some talk a while back about Pulumi supporting PowerShell, but it doesn't currently, unless you want to hack some things with using .NET through PowerShell, which I don't think we want to do. And so the closest we've got to a scripting language is Python. So maybe we've got some IT pros working with us who are familiar with Python. If you're coming from a machine learning background, you also might be familiar with Python. So we're going to use that. Secondly, Python isn't a language that I've spent massive amounts of time working with either. So I will be learning Python to some extent as we do these videos as well, which hopefully means you will get to see some of the more basic concepts, and I will go through some of that rather than if I pick .NET, C#, which I use a lot, maybe skipping over some concepts that are actually useful. So we'll use Python for this. Okay, next we need to install some of the tools that we're going to be using, and there isn't a huge amount. If you've got it or you're happy to go and get it installed, I would recommend you use the Chocolatey tool to actually install these tools. It's much quicker and easier to use. So Chocolatey is available from chocolatey.org, and there are instructions there to install it. You can just run some PowerShell or some command to actually install the tool, and then you can use the Chocolatey commands to install lots of different packages. So you can see here we've got 4 things we're installing. We're going to be using VS Code as our IDE for doing this development. So if you don't already have VS Code installed, you can go ahead and run that. We're going to do all of our examples in this course using Azure. So ideally for this, you're going to have an Azure subscription to work with. If you haven't got one, you can go and get one using the Azure free. So this allows you to create an Azure account for no cost, use a number of services for free for 12 months, others that are always free, and you will also get some credit to use with Azure as well. All the examples we're going to use are going to do some fairly basic services, so things like storage account, web apps, those sort of things. We'll aim to keep them as cheap or free if possible. So things like storage accounts are not going to cost anything unless you put massive amounts of things in them. There's a free tier for app services, so we'll look to use that. Those sort of things. So we'll try and keep the cost to doing this down to as minimal as possible, ideally completely. If you're not working with Azure and you want to use a different cloud provider for doing your testing, that's absolutely fine. You obviously just need to go and have a look at examples from either the Pulumi docs or from the GitHub repos about how to do that with your service of choice. Okay, so we need to install the Azure CLI to work with Pulumi in Azure, particularly on our desktop where we'll be using interactive process. We then need to install Pulumi. So this is the Pulumi CLI where we will run all of our Pulumi commands and will allow us to create projects and those sort of things. And then we need to install Python because that's what we're going to be using to actually write our code. So we can run the choco command to install all of those. I've already done that, but if you run those commands that are on screen, I'll put them in the video description as well. You can run that. The /y on the end will automatically accept the terms and conditions. If you don't want to do that and you want to have a read, obviously drop the /y and it'll let you confirm that you're happy with those. So I've already got those installed. So you can see I'm using VS Code here. That's ready to go. Once you've got VS Code up and running, we also want to install the Python extension. So if you go into extensions and search for Python, you can see there's this one here. It's a Microsoft one. That's the one you want. And we can go ahead and install that. Let me zoom out a little bit. And that should install that. So that should be all we need for the moment. We might need to add some additional things in the future, but those packages should do everything we need to do for now. So what we're going to do now is create a new Python Pulumi project. Have a quick look at what it does when you create that, and then we're going to run it and make sure that we can actually deploy those resources and everything's working. Okay, so to do that, we need to hop over to the command line. I'm using Windows Terminal here and PowerShell. You can use your terminal of choice. It's up to you, whatever you want to use for that. If you're just coming from a default Windows install, you've probably got PowerShell 5 and Command installed. They will work fine. You might want to install PowerShell 7. It's a nicer experience if you want to do that. And I do like the Windows Terminal, but again, you don't have to have any of those. You can use whatever you want. So the first thing we're going to do is create a new folder for where our project's going to live. So I'm just going to create a folder here called Pulumi IT Pro. You can call this whatever you like, that's fine. And we're just going to CD into that folder. So next we want to create the Pulumi project. So we use the Pulumi CLI to do that. So the command we need is Pulumi new, and then we need to select the type of project we want to use. Now, you're not tied into using just one cloud provider in a project. So you can see here, we're going to use your -Python project to start with. So what this will do is it will create a project that's in the Python language, and it will configure it to work with Azure. So it will install the Azure libraries and it will create some example code to work with Azure. That doesn't limit us to just doing Azure in that project. It's just where the starting point is. We can then install additional packages for other tools. We could add a Kubernetes one and then write some code to work with Kubernetes in the same project. That's absolutely fine. This is just the starting point that we want to use. Now, before we actually run that, we do actually need to log in where we're going to store our state. Now, we're going to have a whole video on Pulumi State and how it works, and you can store the Pulumi State in various different places. You can use their service, you can use a cloud provider's place like Azure, you can use Azure Storage, or you can run it on your machine, which is fine for early development work. You're not sharing with others or anything like that. So we are going to use the state storage on our machine for now to keep it nice and simple. We don't have to set any cloud provider pieces up for that. And so if you run the Pulumi login -- local command, that will log into the Pulumi state local on my machine, and that's where it will store that state. Now, I don't recommend using this for anything that you're going to do in production, because obviously that's not backed up on my machine. It's easy to lose. I can't share it with anyone, and we'll deal with how to use proper state providers in the future. But for what we're doing here, just to test things out, that's absolutely fine. So now if we run Pulumi new Azure Python, if you're doing other languages, you can do Azure C#, Azure Java, those sort of things. We're going to use Python. And so we run that and it will start to create our project. It's going to ask us some questions. So the first one is the name of the project. I'm going to keep it as the name of the folder. A description, which you can put what you want. We will put in here, add that in. And then you ask for a stack name. So as I mentioned before, stacks are as akin to Terraform workspaces, but they allow you to configure different environments for you allow you to use the same code but vary things like the configuration and so on for different environments. So we can have a dev stack, a prod stack, a test stack, and all that sort of thing. Now, the default name it gives there is dev, which you can use. That's absolutely fine. But you do need to think about this because you can only ever have one stack with a particular name in a particular state storage. So if we use dev here and we then created another project to do something else, we couldn't use dev again unless we use a different state store. And so often it's useful to actually be a bit more constructive with the name and indicate the kind of project it's for. So we will actually call it IT Pro dash. Now, I mentioned encryption before, so you can encrypt, or you have to encrypt, the secrets in your state file. As we're using local state, it's going to use a passphrase to encrypt the secrets. When we start looking at using other state providers, you can use other means to encrypt the secrets to make your life a bit easier. So the Azure example, when we do that, we can use Azure Key Vault to encrypt our secrets and do that automatically for us. But for this demo, we're going to use a local encryption, and so we need to give it a passphrase. I recommend you do use a passphrase rather than leave it blank. You can leave it blank and just hit enter, but it can be a bit of a pain to use later when it's certain things expect a passphrase. So we are just going to put one in and confirm that. Then whenever you use it, it wants you to unlock using this passphrase. So you can either type it in, or you can actually set an environment variable. You see here the Pulumi_config_passphrase environment variable, so you don't have to do it every time. Now, because this is an Azure specific project, it's going to ask us for one of the configuration values that go into the config file for the region we get. And we'll have a quick look at this in a second. This gets stored in our stack configuration because obviously you want to be able to have different Azure locations depending on whether you're doing a dev deployment or a prod deployment. And this sets that bit up for you. So we are actually going to use West Europe as our deployment location. You can use this config for lots of different things, and we're going to have a whole video on that. But for the minute, just set it to a region that you're happy to deploy to. This now goes ahead and it downloads and installs any of the Python libraries and so on that are required and gets all that set up for us. So we'll just wait for that to do its job and get everything installed. So you can see here it's installing the Pulumi Azure native library. This is what we're going to use to actually create our resources. But again, there's nothing to stop us adding additional configuration libraries in the future. And I'll show you how to do that. Okay, the setup finished. It actually took a little while for me, and it did actually generate an error. So I just want to make you aware of what's happening here. So you can see here it had an issue building the wheel for the Python Azure native library. Looking at a GitHub issue, this seems to be down to long file path name issues on Windows. There's a fairly nested folder this is in, so that's probably why. You can fix this using a registry key to go and allow long file names, and I'll put a link to the GitHub issue in the notes if you experience that to go and get it up. But it's actually not an issue because you can can see here in the yellow, it actually went and ran a setup script to set things up instead. It detected that error and ran this setup script. So everything is set up and working. It's just used an older method to do it. If you want to head that off and you think you're going to have the same issue, you can go and make the registry change to allow long file paths. Obviously, if you're doing this on Linux or WSL, you won't have the same problem. But yeah, that's what happened there. But we should be good to go now. So let's have a look at the files that we created. So I'm just going to open Visual Studio Code in this folder. And you can see we've created a project here. These are the files that we get created. So main.py is our actual Pulumi code, and we'll go over that in a minute. It's created a default git ignore. It's created this configuration file. So you remember when we set it up, we had to set the Azure region. You can see that's added here as part of the config, and we'll go into the config in more detail how that works later. It's also added an encryption salt. This is the salt for the key that we used. The Pulumi.yaml is just the settings for the project, so you can see the description I added here and the name gets added here. Nothing too exciting. And then requirements.txt talks about the Python libraries that we're going to need to actually install. If you're not familiar with Python, this is how pip installs you tell pip how to install the various libraries, I believe. So going back to main.py, which is what we're really interested in, this is where the actual code gets created. And so it's created an example here. And what this example does is it creates an Azure resource group, it creates a storage account, and then it gets the key from that storage account as an output that we can consume later. And this is where we start looking at the actual Pulumi code using Python to create those resources. So let's have a look through what's in here. So the first thing we're doing is we're importing the libraries that we need to consume within the file. So we're importing the Pulumi library, so that's all of the Pulumi library. And then we're also taking the Pulumi Azure native library, which is this one here. But for this, we're only importing the particular resources we need. So rather than reporting every Azure resource that we might ever need, we're just importing storage, the storage account, and resources, which is what includes the resource group. You could obviously import everything. That's going to bloat your project a bit. So in the case of this, we're just importing those particular resources. Then we start creating the resources. And so the first thing we are looking for is the resource group. So we take the resources library. So this references this import we've got there. And if we hopefully my IntelliSense is working. You can see this has got various different properties, one of which is resource group. So we are using that, and then if you hover over it, if you've not used Python Visual Studio before, if you hover over a property, it will show you the things it accepts. And so you can see here the resource group method has a property pattern of resource name. So the resource name is the name that you're going to give the resource in your state file. Actually has nothing to do with the resource name it will get into in Azure. It is just how it's referenced in the state file. And that's all we're passing in at the moment. So the rest of the properties are optional and we're not passing any in. So you will then ask, well, if that resource group, the name here is only for the state file, where is it getting the Azure name from? Pulumi has this capability to auto-generate names if you want it to. And so that's what it will do here, is it will auto-generate the name for the resource group. It's taking the location from that configuration setting, and that's actually all the properties you need for a resource group. And so that's why there's no other properties in there. If we want to give it a name, and generally I don't tend to use the auto-generated name stuff in Pulumi because I generally have to follow a naming convention that's given to me, and I don't want to auto-generate that. So we will see how to do that in the future. But for the minute, I'm going to let it create with this. So this will create the resource group, and it's putting that resource group into this resource group variable that we can then reference later. And we are going to need to use that. So next, we're doing the same sort of thing, but we're creating our storage account. So we've got an account. This is the variable. We're going to stick that in. We're using the storage library, and then we're using the storage account method. Again, the first value is the resource name in the state file. So you can see here, this is what gets passed, what we need to pass in. And then it has a load of other variables or properties that can get passed in to configure the resource. So if you're familiar with doing storage accounts from Terraform or Bicep or so on, it needs things like a resource name, it needs a storage GUI to use the storage account and so on. These are all the properties. Now, this is a slight downside to using Python for this, is that if you use something like .NET, properties is its own object, which then has properties on that, whereas this is everything is within the same object, and you get quite a lot of IntelliSense here that doesn't make it particularly readable. If you have trouble doing that and you want to see what's going on and what properties you need to set for what resource, then you can always check out the docs. So if we head over to pulumi.com, I'll just show you where to find these. If you go into Docs, and if you scroll down, and we want the API reference here, and you basically pick the library one. So we're using Microsoft Azure, and we want storage. So let's just search for that. There's quite a few storage things, so we'll just scroll down to storage. And in particular, we're looking at storage account. And so you can see the details, and you can pick the different language. So we'll look at Python, and this gives us an example of a Python deployment. And then it gives us, there's quite a few examples in here, but then it gives us all of the input properties that are available for you on the storage account. There's quite a lot there. So you can have a look at that, and you can read those different properties and so on to configure what you need. But you can also, sorry, go back to VS Code. You can also just use IntelliSense in VS Code to have a look at those as well. So if you come in here and just press Control Space, which is the IntelliSense, you can see it gives you the various different properties that you can set. And we can, let's turn on enable HTTPS only. We want to set that to true, and then we need a comma. And you can see that will set that up. And there we go. We've hit my first lack of knowledge in Python as we're learning. So Python, the booleans need to be capitalized, so that's true. So you can see here, we're just setting the various properties for the resource, which is not very dissimilar to how you would do it in any other infrastructure as code language. You just need to wrap them in a Python syntax. So, if we move on to the next one, we're setting the resource group name. And if we wanted to, we could just type in a string here, but we actually want to make sure it goes into the resource group we created earlier. So that's in a resource group variable. So we're calling the resource group variable, and then you will see that the resource group variable has a number of properties. So how you can get the ID, the location, and so on. We want the name, so we're getting that from there. So what that will do is ensure that we get the right name, but it also creates a dependency for us. So now we don't have to define it explicitly. The code knows that it must create the resource group before it creates the storage account. Okay. Now, when we look at SKU, the SKU isn't a simple variable. It's not a string or a boolean or anything like that. It actually has a number of different properties within it. And so it's basically its own object, the SKU args object. So we're again using the storage library and creating a new SKU args, and then within SKU args there are a number of properties. And again, if we press Control Space, you can see there are some values that are available on that. We're actually only going to use the name because that's the only thing we're interested in, and we want to deploy a standard LRS storage account. And this is where you have an interesting option available to you when you want to do that. So you can see here from the IntelliSense that name actually has types. It can be a string or a SKU name. And this gives you some flexibility. It makes it easier for you to make sure you set the right value. So we could just use a string. So we could get rid of this, and we could just type in standard. That'll work. But obviously that requires me to know what that is. It also requires me to spell it correctly, which I haven't done there. So that's an example of how you can get that wrong. So one of the benefits of Pulumi and using this programming language is that it has also got a library that can be used to get the values from that are hard coded in there, so that it's effectively an enum, if you're familiar with that term, that lists all the different options, and we can only select ones that will work. So if we delete that, you can see if we hover over again, it'll show a string or a SKU name. So if we do storage.SKU name, that's the library, and if we do dot, that has all the different options that are available to it, and we want standard LRS. And that will ensure the right string is used. So ultimately this translates into a string, but we don't have to type the string. We just select the right value from this library, and that will do it for us. You can see we've got the same here on this kind option. It's got a value. You can either be a string or a value from storage.kind. Again, if you just wanted to type it in, you absolutely can. But if you wanted to make your life easier, use the kind type, and you can see here there are the various different versions. We'll use storage. And so running that will work, and this will create a resource group, and it will create the storage account in it. The last part is we want to get the storage account key from the storage account. And this is a little bit tricky, and we're not going to go into that in great detail today, but when we create the storage account, let's say we want to put the storage account name into a variable. So we'll just create a variable, storage account, we'll spell storage right, name, and we're going to put account.name in there. That'll work. That's because a name is available on the storage account as a property that we can read directly. Unfortunately, because of the way the Azure API works, the storage account key is buried a bit within the resource under a number of different properties. So actually, inside the storage account, you have to run a method called list storage account keys to get the storage accounts, and then from that you get an array of keys, and then you pick the one key out of that. This method is doing that. So it is going to the storage account, and we're passing in the resource group name and the storage account name. It's running the list storage accounts keys method, and it's getting the values and translating them into a particular key that we can then use. Don't worry too much at this point about understanding what this is doing. We will come onto that. You need to understand a little bit more about the apply function for resources, and we'll cover that. We'll probably take a whole video on that on its own, but it's a key thing to understand, but it's a little bit complicated. Don't worry too much about that right now. Just know that this section will get the storage account key and put it in a local variable. And then the last part here, this Pulumi, is creating an output from the program. And we'll see that when we run it from the command line, but basically this is taking the storage account key and exporting it so that it can be consumed by something else. So simplest thing will show up on the command line, and that's probably not what we want to do at this point because you'll get that in plain text. There are ways to protect that, and we'll look at that in the future. But it also means that if you have a second Pulumi program, it can actually consume the outputs of the first program. And so you can chain these things on. So if you want to break up your deployment, and then let's say you have a network deployment that's created by one team and then an application deployment created by another, you can create outputs on the first one that can be consumed by the second one. And that's what this is doing, the Pulumi.export. If you do this in .NET, you would create an output, a variable of type output that would then get set with this value, and that would get consumed in the same way. That's exactly what it's doing. It's creating basically an output called primary storage key, and it's putting that value in there. And you'll see that in a second when we run this from the command line. Okay, so now we've got that program set up. Let's go ahead and see if we can make this work. So back over in the command line, let's just clear the screen. So the first things first, we need to actually log into Azure. So when we run it locally on our machine, it will default to using the Azure CLI login that you're already connected to. There are ways to make it use a service principal or a managed identity if you're running in Azure. We'll come to that later, but for the simplest sake now, we'll just use our Azure CLI Connect. And so I'm just going to run a login to make sure I'm logged into Azure. This will pop up a web page, and I'm just logging in to that web page, and that will log me in. And if you've got multiple subscriptions available to you, then you may want to select the subscription you will want to select the subscription you want to use. So if we do a AZ account set and then -- subscription and the subscription ID or name, and if we spell account correctly, that always helps, and that will just make sure we're using the right subscription. That's what we'll get deployed to. So we're logged into Azure, we've selected our subscription, we now want to run our deployment. And so this is where we get to know a few Pulumi commands. So the first one we can use is Pulumi preview. Now, in our simple example, we don't need to tell it any other information. We're in the folder with our Pulumi file, so it will use that file and it will use the default stack that goes along with that, so we don't tell it anything else. In future, we'll look at more complex commands where you can define what you're running. We will preview. This is going to ask you then for your passphrase if you haven't set the environment variable, which I haven't. So I'll just enter the passphrase. That's unencrypting my secret so it can use it. And this will then go and run and preview what it's going to do. So it's the same Terraform's preview command, which will go and compare what you're asking it to create to what's in the state file and tell you what it's going to do. So you can see here, it's going to create two resources, a storage account and the resource group. That's what we need to know. So we're happy with that. We're going to go ahead and run the Pulumi up command. The Pulumi up command is the same as the Terraform apply command. It will go ahead and create the resources. This will run a preview first. That gives you some more information on, again, what will be created. So you don't always need to run preview. If you can just run up and then you get the option to actually look at what's been going to be created and tell it yes or no. You also have this details option. So you click on that and it'll give you more detail on the resource. It will tell you individual properties that it's going to create, like the resource group name. This is the auto-generated resource group that it's going to create for us. You can see the storage account we created up. It's got those properties set that the HTTPS only traffic is set to true. The type, the kind, and the SKU are set. You can see all that. You can also see that on the preview command. If you use the details flag with Pulumi preview, it will give you the same. I'm happy with that, so I'm going to say yes, and it's going to go ahead and create that for me. And obviously this takes as long as it takes to create resources in your cloud provider of choice. So the resource group was pretty quick. The storage account takes a little bit more time. So that's now finished. And you can see it's gone ahead and created those resources. It created the resource group and the storage account. And then you can see in the output section, we've got that storage account key that's being output. And you can see the keys in plain text, which I shot myself in the foot there by doing that. The key itself will be encrypted in the state file. Because I've chosen to put it in an output as a string, it's showing me that here. There obviously are things we can do to make sure that's encrypted or just not outputted. And generally, you wouldn't want to put a storage account key out like that. I'll be deleting these in a second, so no one's going to use that storage account key. But, generally you wouldn't do that. But just shows you an example of how to get the output. So that's all deployed now. If we hop over to the Azure portal, you can see we've got this resource group created, and you can see it's used the auto-generated naming convention to add this set of digits at the end. And inside of there, we've got our storage account. Again, auto-generated name. We're not going to be using the auto-generated name going forward. I don't really like using that. I prefer to use names I've created, but just to show you how that works if you did want to use it. One of the benefits of the auto-generated naming convention is Pulumi does have the option for it to, if it needs to recreate resources, which sometimes happens if the provider doesn't offer an option to change a value on a particular resource that's already deployed, some of them will require you to actually delete it and recreate it. It can take care of this for you, just like Terraform can. And it has the option to create a new version of the resource before it deletes the old version. Now, obviously, this only works if the names are different, because the cloud provider will complain if you try and create a resource with the same name as an existing one. And so if you use the auto-generated naming, it can do that for you. Generally, I, again, don't like using that. It doesn't, a lot of resources won't work very well in that approach, so I tend not to do it, but you can do that. So now we're back over in the command line. We're happy with those resources. I want to go ahead and get rid of them. So we can now run the Pulumi destroy command, and this will again tell me what it's going to do. And I can then confirm that, yes, I do want to delete those resources, and it will go ahead and delete them for me. And that's where we'll stop for today. So if you're following along, hopefully in this session, you managed to get everything installed that you needed to run the Pulumi project. You were able to create a new Pulumi project with the example code in it. And then you were able to run that code to deploy the resources and then destroy those resources when you were done with them. Next week, we'll be getting into more complex sets of code. We're going to write some of our own Pulumi code to deploy some resources and use some more advanced techniques. But hopefully that gave you a very brief insight into how Pulumi works. You've got everything running, so you're all set for the rest of the series. And hopefully you found it interesting. I will see you in the next video. Until then, have a great rest of your day.